So now let us consider one more important problem where we have to find the derivative using the first principle. So here we have to find f prime of x if the function is sine square 4x, and we have to make use of this limit definition of derivative to find out the derivative of this function, right? So let us apply this limit for writing out the derivative of f of x, that is f prime of x. So we have f prime of x is equal to limit h tends to 0 and f of x plus h. So here fx is sine square 4x. So to get f of x plus h, let us replace this x by x plus h. So here we have sine square 4 times x plus h, and then we have f of x, that is simply sine square 4x, and in the denominator we have h. So now if we closely examine this expression, then here we can see that we have the difference of two sine square terms. So here we'll make use of one important trigonometric identity, that is sine square a minus sine square b is given by the product of sine a plus b times sine of a minus b, right? So this is an important trigonometric identity which can be used here to simplify this expression. So we have a limit h tends to 0 sine square, and here first we can write 4x plus 4h, and here we have sine square 4x divided by h. So now here a is equal to 4x plus 4h, and b is simply 4x. So now we have limit h tends to 0 sine square a minus sine square b divided by h, right? So now we can write sine square a minus sine square b as the product of sine a plus b, that is sum of a and b, and sine of a minus b, that is difference of a and b, and here we have h. So let us first find a plus b. So a plus b is 4x plus 4h plus 4x. So this is 4x plus 4x is 8x, and here we have 4h, and a minus b is given by 4x plus 4h minus 4x. These two terms get cancelled, we are left with simply 4h. So now we have a limit h tends to 0, and here for sine a plus b we have sine of 8x plus 4h. Then we have sine of 4h, because a minus b is 4h, and here we have h. So now we have sine 8x plus 4h times sine 4h over h. So we can now write limit h tends to 0, and sine 8x plus 4h, and then we can write limit h tends to 0 and sine 4h over h. So what we have done here, we have taken the limit first, we have taken the limit with sine 8x plus 4h, then with this term, right, that is sine 4h over h. Okay, so now here when h tends to 0, then this term goes to 0, so we have simply 8x here, and here we can write limit h tends to 0 and sine 4h over h. Now see, we know that limit theta tends to 0 sine theta over theta is equal to 1. So to convert this expression in this form, we have sine 4h over 4h. We can multiply and divide by 4. So here we can write 4, right? Okay, so now the value of this limit is equal to 1 due to this result. So we can now have sine 8x times 4, and this is equal to 4 times sine 8x. So the derivative of sine square 4x using the first principle is given by 4 times sine 8x. So here we can also express this result by using this identity, that is sine 2 theta is equal to 2 sine theta cosine theta, right? So here we can take this 8x as 2 times 4x, so that our theta is equal to 4x. So sine 8x can be written as sine 2 times 4x. This is theta. So we can apply this result. So we have 2 sine 4x cosine 4x, right? So replacing sine 8x by this expression, we can also express this result as 4 times 2 sine 4x cosine 4x, and this is 4 times 2 is 8 sine 4x cosine 4x, right? So either we can use this result or this result.